Hey everyone, welcome to first cycle or first sprint, if you will, where we're going to be looking at the population of a snowshoe hare. So for this particular one, we're going to use a graph to cue that information and kind of pique that curiosity. So it's not necessarily a big question, like a burning question, like why is it like that? In terms of a specific item, it's more like looking at the graph and being like, okay, well, why is it like that? So in this case, we're looking at the snowshoe hare population. We're going to start off asking our students, if you had 50,000 snowshoe hares, what would happen to your population over a period of 10 years? A lot of people will automatically go into your birth and death rates. A lot of people recognize that often hares have more than one or two babies. And so then you're going to see that increase because you're going to have more births than deaths. Maybe they'll recognize that babies have babies. And so it won't be a linear trend. It'll end up being a curve. And then maybe they'll also consider ideas of predators, natural disasters, limiting factors like maybe they run out of food, run out of space, like what's our habitat look like. And so I think that students come up with lots of reasons for different patterns and graphs and why they would look the way they do. And then after students have gotten their ideas out on their own and then in groups about what they think this graph is going to look like, we're going to give them the graph. And so this is a graph of a population of snowshoe hares over 10 years. And we can see there's three key distinct phases in this graph. And we'll walk through why we think that these phases exist and what's going on and can we explain what's happening here. And so over the course of that discourse about can we explain what's happening here, students are going to be developing models or predictions or hypothesis or claims, whatever phrasing you want to use for why the graph looks the way it does. And once we get those ideas flushed out and critically look at so that they're testable ideas, we will then move into our learning component of our sprint. And so through that learning component, we're going to learn things like carrying capacity. We're going to talk about population dynamics and sustainable ecosystems. We're going to look at invasive species and what happens when you have an invasive species. We're going to look at habitat, or more specifically, the food, like energy flow through an ecosystem and the need for energy. We're going to look at, from a food standpoint, we can also look at cycles like carbon cycle, water cycle, nitrogen cycle. And we can also look at the interaction between the spheres. So I think a sustainable ecosystem is really dependent on also the interactions between the spheres. So looking at some of the idea of the different pieces that play and kind of seeing just how complex this web and network actually is. Then we're going to bring in the links, look at what happens to the graph. The kids are going to see this like really beautiful periodic trend that's like, whoa, what is that? And then when we put the links one on top of it and see how they both kind of peak and valley offset of each other, then that will give students a really good idea of what's happening to this particular population. We'll come back, refine our models a couple of times as we go through our learning to better explain what's happening in the graph and better kind of understand the idea and the complexity of population dynamics, while also touching on a bunch of stuff. The space unit in this course also talks about the impact of space ideas onto some of the natural phenomena we experience on Earth. So we can bring some of that in. We talk about the sun as the source of energy. We can get a little bit into photosynthesis, respiration, depending on what your students are looking at for their things. And remember, what we don't get here, we can make sure we cover it in the next sprint. It's not the end of the world, but there's a lot of rich and dynamic ideas that we can talk about here, just trying to explain this simple graph, which actually isn't that simple. So that is the plan for our snowshoe hare sprint, to dive into ecology and take a look at that.